Hi, Algebra 2 students. Welcome back. We are now on Project 1, Lesson 3, and we have another 6 questions, so we're going to dive right in. Prince Digit is analyzing with his chief economist some reports related to several factories in the kingdom. The reports involve polynomials, so Prince Digit needs to know some basic properties of those polynomials. Question 1. The number of cars that would possibly be sold in the next 2 years with the existing business model is modeled by the polynomial c of x equals negative 3x to the fourth plus x to the fifth plus 2.16x to the third, where x represents the number of years after the current year. Oh, and there's a plus 1 in there. This funny, there we go. Our constant is plus 1. Okay. So Prince Digit states that the degree of the polynomial is 4 because it is the exponent in the first term of the polynomial. Hopefully, after going through this lesson, you all know that the degree of the polynomial is defined by the largest exponent. So in this case, it should be 5. Okay. Question 2. Prince Digit states that the leading coefficient of the polynomial, same polynomial, okay, is 1 because it is the coefficient of the term with the greatest degree. So yes, there's an assumed 1 in front of x to the fifth, and that is indeed correct. All right, we're moving really quickly here. Question 3. Which graph could represent the polynomial? Same polynomial as before, okay? And so what we need to pay attention to here is that we have an odd degree polynomial, which means that our graph is going to head off in different directions, okay? One side is going to do this, and it could do anything like this, but then the other side is going to head down. And it's, if you kind of twist things, it's going to be more of an S curve, okay? So let's just scroll through here and see which of these fits that. It looks like the first one does. The second one doesn't because they're both going in the same direction. This one they're going in the same direction, and the last one they're going in the same direction. So the only one that could possibly work here, because it has to head off in different directions if we have an odd degree polynomial, is the first one. Okay. All right, now we're going to switch polynomials. We've got all this. Okay. One of the factories' profits over time can be modeled by this polynomial. And all we need to answer in this one is what is the leading coefficient? So we just have to find the largest degree. We can say that it is 6, and so the leading coefficient is 2. Okay. What is the degree? Well, we already said, okay, it's our biggest exponent here, so it's 6. Cool. Okay, so remember when I said previously that if we had an odd degree polynomial, the graph needs to head off in different directions. An even degree polynomial will be in the same direction. It'll be kind of bumpy. All right, so this is going in different directions. This is going in different directions. This is going in the same direction, and it's a little bit bumpy, so that looks good. Again, this is heading in different directions. So the only one that fits our even polynomial heading in the same direction on both ends of the graph is going to be this third one here. Okay, last question. We've really moved through these quickly. All right, last question. And I've gone ahead and typed the answer here. It says, analyze the two polynomials in the graphs that Prince Digit was working with. Describe the similarities and differences between the polynomial and the graphs. So the differences is that they had different degrees and different leading coefficients, okay? Another difference is because one was odd, it had an S shape, okay, where the ends were heading in different directions. The second polynomial had an even degree, which meant that it was going to be like a bumpy U shape with both ends heading in, both ends pointing up. The similarities is that they were, of course, both polynomials. They only had exponents that were whole numbers, okay? And they were also both continuous graphs. There were no holes and there were no right turns or anything like that. So they were both smooth, continuous graphs. All right, that was super quick, and I hope you enjoyed it, got something out of it, and I will see you back here for the Lesson 4 project. Thanks.